Hey guys, welcome back to Algebra Land. Ready to start solving systems of linear equations? If not, go back to my linear functions videos. But if you are, then let's get going. Alright, so what is a system of equations, you are asking? It is simply two or more equations with two variables binding together, or bound together, whatever, and then so here's an example of what the system is. Now there is supposed to be a bracket with this, but bracket to the left side of these two equations that pairs them together, but I don't have that feature on me, so hey, why hate it when it freezes up on me like that? Okay, so this is a system of equations. This is an example here. So you're going to be learning, the main goal of this chapter here is to solve. That's it. We're mainly just trying to solve. Now, today we're going to be, there are three different methods to solving systems of equations. You could graph them, you could solve them with substitution, or you can solve them algebraically with the elimination method. So, let's see how we can do it. Let's see how we can do this. X plus y equals 2. We're going to graph that one first. So we're going to do 2 divided by 1, because that's a coefficient of y here. Plot that as the y-intercept. 2 divided by 1 equals 2. We're going to graph that line. Then we are simply going to go like this. Now, I will warn you that it is probably best if you try to graph these with a straight edge, unlike what I just did. You're not going to get very accurate solutions if you draw them the way I do. Okay? But anyways, I believe the x-intercept is 3. Negative 3 divided by 2 is negative 3 over 2. Now, what could I say is the solution here? That's a tricky question, actually. Really, it's not. For me, it is at least. So, I will tell you guys that the point of intersection between these two lines is the solution to our system of equations. Now, I think that the solution is 2.5. Negative 0.25. So I'm going to have, so the thing is with the graphing method, this is mainly what we try to use to give you an idea of how systems of equations are solved and what they mean on a coordinate plane. But really, it's not the best method. It's mainly for approximations. So we are going to try to plug in these coordinates and check them. So they have to, so both equations have to be matched in order for it to have a solution. Okay, so we have 2.5. We have 2.5 minus 0.25. I can see we made a little bit of an error here, actually. So I think I'm going to have to take out that 2. Maybe that would be better. There. That sounds better, don't you think? 2.5 minus 0.5 is 2. Now, let's see if we can do it right here. Negative 2.5 plus 2 times negative 0.5 equals negative 3. Okay, you see how hard this is now. It's not a really good method. That's not the best method, okay? I'd say this is a reasonable estimate because we're pretty close to making sure these solutions actually check to both equations. You will get the better solutions by solving algebraically, though. Okay? Okay. Let's see if we can try this again. I'll try this again. We might do a better job here. Alright. How about x plus y equals 2? And 2x plus 4y equals 8. Does that sound better? Alright, well, let's give it a try. 2 divided by 1 is 2. 2 divided by 1 is 2. Graph a line. And then 8 divided by 2 is 4. And then 8 divided by 4 is 2. And so this is the point of intersection. Now I will tell you that this one is easier to know because apparently these two lines right here have the same y-intercept. And if they have the same y-intercept, then they have a solution when in a system. And so we can label this as 0, 2. Because 0 plus 2 equals 2. 2 times 0 is 0. Plus 4 times 2 is 8. 0 plus 8 is 8. Alright. That's all I need to do for today. Okay, it's pretty simple, guys. Nice. I just want to give you an idea of what... give you an idea of how we can solve systems of equations by graphing. Next time, we're going to be learning how to solve them algebraically. It's going to get it might get a little bit more complex, but I promise you that with this basic definition down, I think you can do well. I believe in you. Alright, so I think that's it for now. Alright, so thank you so much for watching, guys. Be sure to leave a like and subscribe, and if you like this video, tell your friends. And, well, I think that's it. Go on. Don't be shy. Actually, that would be if I was trying to get you to come. Anyways, skedaddle. See you later. Adios.